Hi friends, welcome to our YouTube channel. Today we have to discuss about one of the most important concept in C programming is differences between structure and union. Both structures and unions are used for storing the heterogeneous data type elements under a single variable. Now, what are the main differences between structure and union? Okay, the first one is we have to use a keyword called struct to define the structure. Suppose we want to create one structure, compulsory we have to use the keyword struct in the case of structure. While in the case of union, suppose you want to create a union, first of all, we have to use a keyword called union. By using that keyword, we have to define the union. Second point is how to find out the size of the structure. Okay, the size of the structure is equal to the how much amount of memory occupied by each and every data member in the structure. That is nothing but sum of the memory occupied by each and every data member is called as the total size of the structure. For example, we can take the student structure. The data members are roll number, name, course, height and weight. What is the size of the structure student? So the total size of the structure student is sum of the memory occupied by each and every data member, or sum of the sizes of each and every data member is nothing but total size of the structure. So here int roll number, the data type is int. How many bytes that is occupied by the roll number? So that is 2 bytes. Next, char name of 20. Here character data type occupies 1 byte. So how many number of characters are there? 20 characters are there. 20 into 1, that is equal to 20 bytes. Next, char course of 20. The data type of course is character. Character data type occupies 1 byte. How many number of characters are there? 20. 20 into 1. So that is equal to 20 bytes. Next, height data type is float. Float occupies how many bytes? 4 bytes. Weight data type is float. So float occupies 4 bytes. So each and every data member of the structure student occupies this much amount of memory. Sum of the bytes of the memory occupied by the structure student is, so 2 plus 20, 22, 22 plus 20, 42, 42 plus 4, 46, 46 plus 4, that is 50 bytes. So the total size of the structure student is, so that is 50 bytes of memory required for storing this entire structure. Therefore, the total size of the structure is 50 bytes. Sum of the sizes of each and every data member in the given structure student is nothing but total size of the structure. Next, in the case of union, the total size of the union is nothing but how much amount of memory required by the largest data member in the union. That is nothing but size of the union. Okay. So consider this example. So union, student. So these are the data members of the union. Okay. So here whatever the data members are there, the same data members are all also taken in the case of union. Okay. Here it occupies 2 bytes, same in the structure. It occupies 20 bytes of memory. It occupies 20 bytes of memory. It occupies 4 bytes. It occupies 4 bytes. Among all the data member, which data member occupies largest amount of memory? So that is 20 bytes. Maximum of 2, 20, 20, 4, 4. So that is equal to 20 bytes. So now the total size of the union student is 20 bytes, because here the largest data member occupies 20 bytes. So the size of the union is also 20 bytes. Next point in the structure is every data member within the structure is assigned a unique memory allocation. Consider this example, struct example. Here structure name is example and the data members within the structure are int A, float B, char C. Okay, 3 data members are there in the structure called example. Each and every data member is assigned a unique memory location. Here I am taking this data member A, its data type is int, it occupies 2 bytes. Next, here data member is B, its data type is float, float occupies 4 bytes. Next, another data member C, its data type is char, it occupies 1 byte. So 3 data members are there. For 3 data members, we have to assign a unique memory allocation. Okay, for this data member, unique memory allocation. For this data member, unique memory allocation. For this data member, unique memory allocation. Okay, how many data members are there in a structure? For each and every data member, we have to allocate a unique memory allocation. Okay. Next one, in the case of union, a memory location is shared by all the data members of the union. For example, we can take the same structure like union. Union name is example. The data members are int A, float B, char C. Okay. Among all the data members, which data member occupies largest amount of memory? That is float. Float data type occupies largest amount of memory. Int occupies 2 bytes, float occupies 4 bytes, character occupies 1 byte. So among these, float occupies largest amount of memory. Okay, so therefore size of the union is equal to 4 bytes. So this is the size of the union is 4 bytes. This 4 bytes of memory is shared by all the data members within the union. So data member is A, its data type is int, it occupies 2 bytes. Next one, data member is B, its data type is float, it occupies 4 bytes. Here data member is C, its data type is char, it occupies 1 byte. The same memory location is shared by 3 data members within the union. Okay, so in the case of union, a memory location which is occupied by the largest data member in the union, that is shared by all the data members. Whereas in the case of structure, so each and every data member we are assigning a unique memory allocation. Okay, this data member is stored in a separate memory address. This data member stored at a separate memory location. This data member is stored in a separate memory allocation. Okay. Next point is which one is faster among the structure and union. So structure is slower because for each and every data member that is stored in a separate memory location. But whereas in the case of union is faster because a single memory allocation, a single memory location is shared by all the data members within the union. Okay, so that single memory location occupied by the largest data member within the union. Okay, so union is faster because it requires the storage space of the largest data member. Whereas in the case of structure is slower because it requires the storage space for all the data members in the structure. Next point is all the structure members can be initialized at a time. Okay, so here consider this example, struct example. In this one, there are three data members are there, int A, float B, char name of 20. We are creating a variable for the structure example is E. Okay, struct example E is equal to, so here the first data member is int A, its value is 18. Second data member is float B, its value is 3.5. Third data member is char name of 20, its value is Sai. So whatever the string is there, that string can be put in double quotes. Okay, so next we have to print that values by using dot operator. We are accessing all the data members of the structure by using structure variable and dot operator. So printf, first data member data type is int. We are using the format string %d. Second data member data type is float. We are using %f. Third data type is character array. We are taking a string. So we are taking the data format is %s. We are accessing this data member by using the variable e dot a. Next, we are accessing this data member by using variable e dot b. Next, we are accessing this data member by using the structure variable e dot name. Okay, so here we are initializing all the data members at a time. Then what is the result we are getting? So e dot a value is 18 printed, e dot b value is 3.5 printed, e dot name value is Sai printed. Okay, so all the data members of a structure can be initialized at a time. Okay, then we are accessing all the data members from the structure by using the structure variable and dot over period operator. Then whatever the values we are initializing, that values are printed as it is in the structure 18, 3.5 Sai. Whereas in the case of union, all the union data members cannot be initialized. Okay, so we can initialize only one value at a time in the case of union. So consider this union example. Its data members are int a, float b, char name of 20. We are creating the union variable for the example is u. So union example u is equal to, so I am initializing for this data member 18, for this data member 3.5, for this data member Sai. When we are printing these values by using the dot operator and union variable, okay, so what values we are printed? Only the first data member can be printed correctly. The remaining data members are corrupted. The remaining data members cannot be printed correctly. The remaining data members are corrupted. Okay, so only the first data member can be printed correctly. The remaining data members can be printed incorrectly because union can initialize only one member at a time. Only one member can be initialized. The remaining data members cannot be initialized in the case of union. Okay. So only 18 is printed, the remaining values are printed incorrectly. The remaining data members are corrupted. Whatever the first value we are initializing, that first value is printed correctly. The remaining data members are printed incorrectly or are corrupted. Okay. Next one is, this is the simple definition of structure and union. Both structures and unions are used for storing heterogeneous data type members. Okay, so structure is a heterogeneous collection of data members grouped together under a single name. Okay, so these are the heterogeneous data type members. They are grouped together under a single name called as E. Okay, this is the structure variable. We are grouping different data type members. Heterogeneous means different data type members under a single name is nothing but example. Okay, so structure is a heterogeneous collection of data members grouped together under a single name. So these are the different data type members. They are grouped together under a single name called as example. Okay. Next, whereas in the case of union is also a heterogeneous collection of different data type members under a single name. Okay, so these are the different data type members. They are grouped together under a single name called as example. Okay, but here how much amount of memory occupied by the union? So whatever the largest data member is there, that much amount of memory location is occupied by the union. Okay, that memory location is shared by all the data members. Here it occupies 2 bytes, it occupies 4 bytes, it occupies 20 bytes. So among the 3 data members, largest data member is this one. So how much amount of memory is allocated for the union? 20 bytes. This 20 bytes of memory location is shared by all the data members in the union. That is represented in the previous point graphically. Please observe that point. Next point in structure is we can access any member at any time from the structure. Okay. For example, so this is the given structure struct example. These are the data members of the structure. We are creating a variable for the structure. Example is yes. By using dot operator and a structure variable, we are accessing the data members. So s dot a is equal to 18 semicolon. S dot b is equal to 3.5. Next one, strcpy s dot name comma Sai. This string is copied into s dot name. Therefore, s dot name contains Sai. Now we are printing the values. Printf, this is %d and this is percentage F, this is percentage S. So S dot A comma S dot B comma S dot name, S dot name. Okay, so we are accessing all the data members of the union, all the data members of the structure at a time. So that values are printed correctly. 18, 3.5, psi. Okay, we can access all the data members of a structure at any time. At a time, we are accessing all the data members of the structure, and also each and every individual data member can be accessed at any time. Okay, all the data members can be accessed at a time, and each and every individual member can be accessed at any time in the case of structure. So the same values we are printed. Whatever the values we are initializing, that values are printed in the case of structure. But in the case of union, we can access only one data member at a time. Okay, we are initializing or we are accessing all the data members, then corrupted values are printed. So in the case of union, only one data member can be accessed at a time. Okay, so consider the same example in the case of union. Union example, these are the data members in the union. This is the variable that is created for the union. I am initializing u dot a is equal to 18, u dot b is equal to 3.5, and strcpy psi is copied into the u dot name. When we are printing these values, okay, what is the values we are printed? Whatever the last value that is accessed, this value is printed correctly. The remaining data members are printed incorrectly. In the place of that, we are printed garbage values. Okay, whatever the last data member that is accessed, okay, that data member can be printed correctly. Psi is printed correctly. The remaining data members are printed as garbage values. Okay. Compared to the previous point, when we are initializing all the data members in the case of structure, all the data members are printed correctly in the case of structure. But in the case of union, only the first data member can be printed correctly. The remaining data members are corrupted. But here in this point, so all the data members of the structure can be accessed at a time, and each and every data member can be accessed at any time. So there is no problem in the case of structure. Whatever the values that we are initializing, that values are printed correctly. But in the case of union, whatever the last value that is accessed, that value can be printed correctly. The remaining values contains the garbage value. What is the last data member that can be initialized or accessed? So that is name. Okay, that name is printed correctly. The remaining data members, first two data members can be printed as garbage value. So this is the very important point. Next point in the structure is changing the value of one data member will not affect the other data members in the structure. Suppose we are changing the value of one data member, it will not affect all the data members within the structure. Consider this example, struct example. The data members are int a, float b, char name of 20. We are creating a structure variable is yes. So we are initializing all the data members at a time. 18, 3.5 psi. Now we are printing that values by using dot operator and structure variables. When we are printing, so in the s dot a value is 18, that is printed. S dot b value is 3.5, that is printed. S dot name is Sai, that is printed. Okay. Now we are changing the value of this data member, float b. Okay, we are changing previous, its value is 3.5. Now I am changing the value for floating point data member, that is b equal to 7.5. Now we are accessing s dot b is equal to 7.5. Again we are printing all the data members. Okay, so when we are printing all the data members, okay, 18 as it is printed, in the place of 3.5 printing 7.5, because we are modifying the value of this data member. Whatever the value that is modified, that modified value is printed. So in the place of 3.5, so the modified value 7.5 is printed. Next one is Sai as it is printed. Whatever the data member we are changing its value, that modified value will be printed. There is no effect of other data members in the structure. The remaining data members, there is no change. Here 18, here 18. Here Sai, here Sai. But whatever the changes that are done for a data member value, that modified data member value can be printed. So in the place of 3.5, 7.5 is printed. Okay. So changing the value of one data member will not affect the remaining data members in the structure. Whereas in the case of union, changing the value of one data member will affect the values of remaining data members in the union. Okay, consider this example. Union example, these are the data members. I am creating the variable for union u is equal to 18, 3.5 psi. We are printing that values. First we are printing that values only all the data members within the union are initialized at a time. Only the first value can be printed correct. First data member value can be printed correctly. The remaining data members are corrupted. So first data member value is 18. 18 is printed. The remaining data members contains the garbage values. Okay. Next, I am changing the second data member value. So what is the second data member? Float b. Okay. So u dot b is equal to 7.5. Previous value, that is a 3.5. Now I am changing the value of the second data member, that is a 7.5. After modifying the second data member value, again we are printing. Again we are printing all the data members values. Okay. So whatever the data member value we are modified, that data member can be printed correctly. That data member value can be printed correctly. The remaining data members contains the garbage values. Okay. Here in this case, in this statement, okay, what is the resultant value? So 18 garbage value, garbage value. Okay, after modifying the second data member value, okay, again we are printing all the data members. Whatever the data member that we are modified, okay, that value is printed correctly. Okay, the remaining data members values are also changing. Okay, this modification can affect the remaining data member values. So now this is garbage value, this is the garbage value. Changing the value of one data member will change the value of other data member. In the previous case, only 18 garbage value printed. we are changing the value of second data member, that is float B. So these changes will change the values of remaining data members. In the place of 18, garbage value printed, but here garbage value, here garbage value, but in the place of this garbage value 7.5 is printed. So this is also very important point. In structure, syntax for creating a structure. So struct, tag name, and within the braces we have to write the data members. Data type member 1, data type member 2, data type member n. After closing brace, semicolon compulsory. Here syntax of creating a union tag name. Here tag name is nothing but here structure name, here union name. Here the data members we have to write within the curly braces. After that we have to write the semicolon. So what is the difference between the syntaxes of these two structures and unions? Only here we have to use the struct keyword, here we have to use union keyword. The remaining all are same. Next one, syntax for creating a structure variable. Okay, struct, structure name, variable name. Okay, how many number of variables that are created that are separated by commas? Okay, so example, so this is the example and this is the creating a variable for the structure. Yes. Okay, struct example. So this is the tag name or a structure name and these are the data members. We are creating a structure variable yes for that structure. Next here syntax for creating a union variable is union name, variable names. Okay, so any number of variables we are creating for a union or any number of variables we are creating a structure, that variable names are separated by comma. Either single variable we are created or are multiple variables we are also created. So if there are multiple variables we are creating for a union, that variable names are separated by a comma. Suppose if we are creating a single variable, we have to write in this way. So union name is example and these are the data members and we are creating a union variable, that is u. Suppose u1 comma u2 is there, union example u1 comma u2 semicolon. So two variables that are created for the union u1 and u2, these are separated by commas. In the same way here also s1 comma s2 variables are created. Suppose for this structure example we have to write struct example s1 comma s2 semicolon. So these are the 13 differences between structures and unions. Each and every difference can be explained with the example. So thank you for watching this video. Please utilize this video. I am explaining very clearly each and every point with example. Thank you for watching this video. If you like this video, please click on the like button and please share this video to your friends and classmates. If you like this video, please subscribe my channel name. So Divvela Srinivasa Rao.